Hi, good morning, good evening, good afternoon. Thanks for joining me. My name is Greg Pepper, and I'm a security architect here at Checkpoint Software Technologies. And across the 15 plus I've been here at Checkpoint and 20 years that I've been in the IT security industry, this transformation into cloud and this desire to move faster is something that has really revolutionized all of IT and rocked InfoSec's world. And our friends within the DevOps world, which are driving our cars faster than ever, are pushing our organization to the brink. However, I would state that security has just as much ability and shared responsibility to keep up with DevOps, allowing SecOps to move at the speed of DevOps. And that's part of what we're going to talk about here today, is how do we help your organization migrate to the cloud securely? Now, along the way, there are many changes that are happening within the organization. Virtual machines are lifting and moving into public cloud. Applications that were previously built on-premise are being rebuilt in entirely new ways. Cloud-native ways even, where no longer the traditional confines of a web tier, an app tier, and a database running on different physical and virtual machines is the common construct for deployment. These cloud-native workloads may be entirely serverless, where now they're using platform as a service and function as a service and the database as a service. You no longer own the responsibility of the virtual machines. However, you still own the responsibility for security, right? And when we look at that shared responsibility a little bit later on, irrespective of software as a service, platform as a service, function as a service, infrastructure as a service, your private cloud as a service, all of them require the same level of security. But how you secure those cloud-native workloads is different. When you no longer own the network, security controls, and the infrastructure, right, we have to have a new approach for providing common capabilities to monitor for access, identity, threat mitigation, data usage, logging, monitoring, etc. And what we're going to do is share some of these best practices that Checkpoint has learned. In 25 years plus we've been in business as a leader in the space. But in the last 5 to 10 in particular, on how do we enable security to keep up with DevOps? How do we enable security to be an enabler to this migration in the cloud and allow SecOps to keep up with DevOps? Now, as we move into the public cloud, cloud means many things to many people. For some of us, we've made substantial investments in our traditional data centers to bring that more software-defined experience. And whether that's investments in SDN technologies like VMware NSX or Cisco ACI, or bringing Nutanix Flow, or some other OpenStack Neutron-based solution into our physical environments, but we're still not having a full cloud experience with integrated automation and orchestration. Right? We've been provisioning additional tools from commercial or open source or other vendors to help us automate and orchestrate the traditional networking and security and computing and storage configurations. Now, as we move into this middle column into Hi, good morning, good evening, good afternoon. Thanks for joining me. My name is Greg Pepper, and I'm a security architect here at Checkpoint Software Technologies. And across the 15 plus I've been here at Checkpoint and 20 years that I've been in the IT security industry, this transformation into cloud and this desire to move faster is something that has really revolutionized all of IT and rocked InfoSec's world. And our friends within the DevOps world, which are driving our cars faster than ever, are pushing our organization to the brink. However, I would state that security has just as much ability and shared responsibility to keep up with DevOps, allowing SecOps to move at the speed of DevOps. And that's part of what we're going to talk about here today, is how do we help your organization migrate to the cloud securely? Now, along the way, there are many changes that are happening within the organization. Virtual machines are lifting and moving into public cloud. Applications that were previously built on-premise are being rebuilt in entirely new ways. Cloud-native ways even, where no longer the traditional confines of a web tier, an app tier, and a database running on different physical and virtual machines is the common construct for deployment. These cloud-native workloads may be entirely serverless, where now they're using platform as a service and function as a service and the database as a service. You no longer own the responsibility of the virtual machines. However, you still own the responsibility for security, right? And when we look at that shared responsibility a little bit later on, irrespective of software as a service, platform as a service, function as a service, infrastructure as a service, your private cloud as a service, all of them require the same level of security. But how you secure those cloud native workloads is different. When you no longer own the network, security controls, and the infrastructure, right, we have to have a new approach for providing common capabilities to monitor for access, identity, threat mitigation, data usage, logging, monitoring, etc. And what we're going to do is share some of these best practices that Check Point has learned. In 25 years plus we've been in business as a leader in the space. But in the last 5 to 10 in particular, on how do we enable security to keep up with DevOps? How do we enable security to be an enabler to this migration in the cloud and allow SecOps to keep up with DevOps? Now, as we move into the public cloud, cloud means many things to many people. For some of us, we've made substantial investments in our traditional data centers to bring that more software-defined experience. And whether that's investments in SDN technologies like VMware NSX or Cisco ACI, or bringing Nutanix Flow, or some other OpenStack Neutron-based solution into our physical environments, but we're still not having a full cloud experience with integrated automation and orchestration, right? We've been provisioning additional tools from commercial or open source or other vendors to help us automate and orchestrate the traditional networking and security and computing and storage configurations. Now, as we move into this middle column into our public cloud, our infrastructure as a service, well, Microsoft, Google, Amazon, Oracle, AliCloud, and others have built a single unified portal, a single set of APIs, a common control plane for the entirety of that virtualized data center. So what was previously isolated, separated at both layer 1 through 7 and 8, 9, and 10 within our physical data centers, has now been broken apart into a single combined cloud platform. And this creates a unique challenge, especially around shared responsibility, because the users that have identity and access rights within the cloud often have access rights to everything. And as we'll see here a little bit later on, it's the identity and access management of some of these services that becomes as critical or more critical than the traditional network perimeter firewall. And we know we've been the firewall guys for 25 years. This is our wheelhouse. The funny thing is that more and more of our customers are realizing that, hey, why do I have to be in the business of managing the application anyway? Can't we just ship this off to a software as a solution? And whether it's our Office 365, our Salesforce, our Dropbox, our Workday, our ServiceNow, our G Suite, or maybe even the security technology itself is in as a service. I've got the firewall as a service, my secure access services edge. Maybe you're using your SIM as a service as an example, or your firewall manager as a service. The key though is that all of these different software-defined workloads, whether they're SaaS, IaaS, PaaS, FaaS, public cloud, private cloud, we have the shared responsibility to protect them. Now I want to talk and tell a very simple story about how all of our data centers started very simple and have become very complicated. Now, when we think back to the Three Little Pigs, one of the simplest stories of all, right? We built these data centers. We built our straw. We built our wood. We built our hardened environments, our bricks. And maybe this was our development and our staging and our production environments. And in the beginning, we had one common set of development, staging, QA, and production workloads to protect. And we had these huge quarterly releases, and we had months to prepare as the business was ready to roll out the latest iteration of our website, our ERP, our medical record system, our student information systems, whatever those critical business workloads that you've managed in your physical data centers, you built them, you cared for them, and you wanted to protect each and every one of them. But let's be honest, the level of strength and security that you've invested in production was not often the same that made it into stage, and often is, if ever, built into the development environments, right? The development environments are quick, they're weaker, they're easy to stand up but easier to tear down. And they're very easily blown over when the big bad wolf comes. Now, what started as a very simple architecture with 3 environments for our businesses to manage and maintain has multiplied We lifted and shifted and moved them into the cloud. We're deploying them faster than ever. Maybe now we've taken that one data center that we had and we've multiplied it in a cloud provider times multiple geographic regions. Or maybe via design for business continuity and disaster recovery, I took that application that was previously my one data center only, and I'm now deploying it in Amazon and Azure and Rackspace and Google and IBM to distribute my risk and my workload and my billing, right? And what used to be months and quarters to prepare is now weeks to prepare, because they're now starting to automate and orchestrate these workloads faster than ever. And then the developers and DevOps said, we can do this even faster. We can do weekly builds. The bad guys now are coming in days, hours, weeks, minutes. We're deploying new workloads at a rapid rate, which is a good thing. But are these houses being built according to code and compliance and best practice? And will they withstand the big bad wolf when the big bad wolf comes and blows that house down? Now the crazy thing is that when we look one step further around the corner, we're now building these application workloads in an entirely serverless way. We're using these cloud-native capabilities, right? We're using Lambda functions. We're using their content delivery network, their DNS services, their load balancing service, their database as a service, the storage as a service, the artificial intelligence as a service, and on and on and on. And these builds, which were happening daily, are happening every minute. They're continuously happening. And the automation and orchestration of our CICD pipeline is taking what was very formerly a simple development, staging, and production environment and multiplying this at an exponential proportion. Now, as the information security practitioner responsible for keeping the business out of the news for the wrong reasons and up and running for the right reasons, this is the challenge that we face. Is even if you're 5 or 10 people in a garage, you might have hundreds or thousands of functions in the cloud. Or if you're a large bank or healthcare or government organization, you are consuming all of this at a pace faster than ever. Right? And you're determining, do I still need to run this workload in my data center? If not, can I move it to cloud? Or better yet, can I consume it as a software as a service first and decommission the legacy workloads? Now, depending upon your organization, the technology and the layers 8, 9, and 10, that being the people, the politics, and the money, will help you determine whether or not your workloads are going to live in your physical data centers, whether or not you're going to lift and shift those workloads and move them into the public cloud, or am I going to just decommission and migrate to a software as a service altogether? Now, add to this the recent changes to our technology, business, and global healthcare climate. Where it used to be a majority of our employees might come to a headquarters location or a branch office, and maybe a portion of the organization was virtual or work at home. Well, now a majority of our users are remote work from home, and that may be the new norm for a much longer period of time. The amount of users which were previously in the headquarters directly connected to the data center is much less than it ever has. And those branch offices, which previously connected through expensive MPLS lines or complicated VPNs, well, if they're just going out the internet to talk to my software as a service and all my applications are running in the cloud, well, maybe I need a software-defined wide area network to help manage connectivity to the branch office and the cloud and the data center. And that's an entirely new set of software-defined technologies that our customers are evaluating and consuming and deploying. But regardless of where we are along this evolution and migration, that shared responsibility for security always exists. Now, as we can imagine, in the beginning, when we had bare metal and we owned all of our assets, we had all of the control. We plugged it into our data centers. We determined who can physically access them. We managed the software that went on it at the BIOS and the operating system and the application. And then we started to virtualize these things, and we've had massively large-scale number of VM sprawl, right? And then we've realized, wow, we can use this mainframe-like technology around containers, and rather than having to have a dedicated virtual machine that's gigabytes in size, I can run containers that's megabytes in size, right? And now we went from having a couple of pods of dedicated standalone containers to having multiple pods that are automated and orchestrated. And we continue to move faster as we move along the horizontal axis. But as we move more and more into the public cloud, as we move more and more to someone else's computer, as someone likes to refer to it as, we lose some of the control. Now, losing control is not always a bad thing because we lose some responsibility. However, we are responsible for our data and our information and our identity across the board. And when you combine a lot of the shared responsibility models, this is one I happen to pull out of CISO Security Magazine here. But the key thing to understand is you have a shared responsibility across every member of the X and Y axis on this screen. And even where we have those blue dots, where the cloud provider is responsible for the physical or the host infrastructure control, right? You still have a dual shared responsibility in every one of these scenarios. One, you have the shared responsibility to use all of the built-in security from those providers. If I'm using FAS, PAS, IaaS, my on-premise, all of the vendors have security options. There's dozens, hundreds, thousands of security settings that you have responsibility for. Did we turn them all on? Are they managed according to best practice? Are they meeting governance and compliance? But equally, you have the shared responsibility to bring security with you. Now, we are one of many vendors that offer security solutions for serverful and serverless, for cloud access security brokers, network virtual appliances and cloud marketplaces, traditional network security and endpoint security, serverless and secure access services edge, right? These are many categories of which we are one of many vendors out there. But you as the end user have the shared responsibility. You, one, have to turn on all of the built-in controls. Use them. They're good. They're at minimum your best practice. However, you have the shared responsibility to bring security with you. You have the opportunity to choose a vendor like Checkpoint or one of our competitors or an open source solution as an example to augment the built-in controls, to enhance the security at the Lambda function, to enhance the security at the virtual network edge, to enhance the security within the hypervisor, and definitely within our traditional on-premise. Now, as we've seen, our modern application workload has been turned on its head. What we used to do in the past with a traditional router, firewall, load balancer, web tier, middleware, database server with VLANs and routing and switching and servers and storage, oh my, we're now building in cloud native ways. We're using container services for the automation and orchestration and deployment of those container pods. We're just owning the code and no longer the Apache infrastructure and the app intelligence plugged into it. We're using cloud native software-defined capabilities for DNS and load balancing. And then we're consuming our database and our storage as a service. And we're paying per transaction. We're paying pennies and micro pennies per function. But shavings make a pile. And collectively, just because we've built it in a cloud native way, doesn't mean it's one, secured out of the box. Again, we're going to turn on the security, but we're going to add to it that additive security layer. Now, when you think about the challenges of the security model for maintaining posture, visibility inside the workload, some type of controls and audit around the network, and then collecting the logs and the analytics along the way, well, the same challenges exist in IaaS, PaaS, FAS, SaaS, my legacy environment as well, right? How do we gain that level of visibility? The firewall is one of many tools. It is not the only tool, right? And now that we've built these things in a cloud native way, or even in an IaaS way, there is no one perimeter. We could spin up internet gateways on demand, build an entirely new VNet and VPC with the point and click of a few seconds. And before you know it, whether it's through misconfiguration, sloppiness, reuse of overly permissive settings as an example, very quickly our workloads can get replicated at massively large scale whether we want it or not, and whether we know it or not. But on top of that, we're now using a whole bunch of new software Some of it's commercially delivered, some of it's open source, right? And as we've seen here, if I'm pulling in a module into my code or my container that has a known vulnerability or has embedded access keys or default weak credentials, and I'm deploying them in these ways without locking down the code and the configuration, well, we're increasing our attack surface, right? And we can't sit here and say, oh, it was my cloud responsible, it was my cloud provider's responsibility, it was my software as a service responsibility. Because if and when the breach happens in their root cause analysis, right, and our incident response does a lot of cleanup with our customers, helping them to understand what went wrong, how can we have detected it faster, how can we respond faster, what do we do to prevent it down the road, and how are we better prepared when it happens again to mitigate and remediate the situation. Right? And there's not one product or process or person that's going to come in and address every one of these challenges. But there are things we can think about and do to help us address some of these security challenges as we move into cloud. So let's think about this security model and how do we, one, turn it on its head, but at the same token, do exactly what we've done for the last 25 plus years. When we think about the fundamentals of having continuous security that has visibility, that has preventative capabilities, that offers governance, and can work across workloads, well, this is what we're all trying to achieve. We at Checkpoint are trying to achieve this. We've been building many of our newest applications, not in our traditional way where we package and sell you some software and you deploy it on premise, but as our own software as a service. So for us as a SaaS provider and a deliverer of security solutions, our security is the utmost importance. And for us, learning how to maintain visibility in Cloudnative, learning how to have mitigation and threat prevention capabilities, and maintaining governance and compliance is just as important as it is for us, as it is for you. So what are some of the security considerations? Well, in some way, they're exactly the same as what it was before, right? When we think about that firewall, well, we used to have the Checkpoint or Cisco or Juniper firewall at the edge or one of our other competitors. But when we deploy these cloud-native workloads, well, they're not sitting behind your network perimeter. They're out there on the internet with some basic access control lists. And the configuration management for this now is only an API click away. And they're constantly being deployed and redeployed and changing IPs and fully qualified domain names. Are you going to change a firewall every single time that DevOps is deploying new code level infrastructure? Probably not. You'd spend a lot of time making firewall changes. And as the firewall guys, we know nobody wants to make firewall changes. Now, when we think about the code itself, the infrastructure of the code is covering so many elements of the deployment. It's got the VNet and the VPC. It's rolling out the virtual machines. It's bootstrapping the configurations of the firewalls. It's potentially living in its own software repository where it's being checked in and checked out. And it's continuously being automated and orchestrated for deployment on demand. Now, when we think about visibility, right, in the old days, we had an audit trail in our compute, in our hypervisor, our network, our security, and it's very easy to go find the information we're looking for, or easier, not very easy. Today in cloud, everything is now being consolidated into a single control plane. And when we think about things like the combination of VPC flow logs and CloudTrail events, or the audit trail within Azure and their network security logs, right? We're stitching together a multitude of information about network activity, application activity, administrative activity, and we have more information than ever. And identifying what's important and what's noise has become a bigger challenge than ever. More compute, more servers, more serverless, more logs, more audits, all right? There's more things for us to constantly monitor. And this acceleration into DevOps, these micro builds, is great. But also now it's created this additional layer of monitoring. There's more code to check in. There's more builds to analyze. There's more tests to run, more automation and instant response. And I now have more technologies than ever that I'm trying to weave into this intricate platform. As we mentioned, as a lot of these control planes are moving into the cloud, the identity and access management roles within that cloud are more critical than ever. In our traditional physical world, we had separation of technologies. So the people that were the VMware administrators, Well, they didn't log into the routers and switches. Maybe the people that logged into the firewalls, they didn't necessarily have full access into the routing and the switching, right? And potentially the load balancers may be managed by a different team, and the SSL certificates and the web server configuration, and on and on and on. We had natural separation of duties. In the cloud, all of those duties combine into a common set of APIs, a common framework, and through identity and access management, we create the role-based access controls. But understanding the least privilege model in an identity world is a lot harder than it used to be, right? There's thousands of identity and access management roles in the cloud. Do you know which ones are needed by NetOps, SecOps, DevOps, cloud infra teams? Many of our customers don't. And what we've seen time and time again is that a combination of overly permissive access roles, weak security credentials, or stolen harvested credentials or access keys that were maybe uploaded automatically in that pipeline but weren't secured and protected, allows people to gain access to your environment, allows them to use your automation and your orchestration against you. I'll share with you a quick story where one of our customers inadvertently through their CICD pipeline uploaded some access keys into GitHub. And these access keys had root level permission across the entirety of a subscription. Well, hackers found this information and used it for their benefit. They didn't take down the applications, quite the opposite. They used their environment for their own personal gain. They deployed their own Bitcoin miners as an auto-scale group within the customer subscriptions. And ultimately, IT didn't know what was going on. They really weren't watching. They didn't have least privilege identified. And the fact that this auto-scale group that was deployed and continuously growing for the next 30 days, it really didn't catch anyone's eye. But you know who caught it? The accountants, the finance teams. The Amazon bill showed up next month with an extra 0 on the end. Because the bad guys were doing Bitcoin mining in the customer subscriptions because they had very weak identity and access management and access keys and automation and orchestration around security identification. And they were not implementing a least privilege solution. Now, as I mentioned in the beginning, there is not a single product, a single process, or even a single person who's going to be able to come in and magically deliver an ultimate security solution. All right, we are one of many vendors who have security solutions that integrate well with others. And we do some things well and we do some things not well. And there are things that are in Check Point's wheelhouse and there are things that are not going to be in our wheelhouse. But the key for you is to choose technology partners that play nicely together. It's the interoperability between a vendor that makes you best of breed. It's not about buying a single holistic security solution from one vendor that says, I've got everything you need, buy my enterprise agreement and you're going to be securing your everything. Right? However, understanding what are the right technology products, who are the people, and what are the processes to integrate them and allow you not to just think about a single workload, a single project, a single problem, and a single product, but a holistic solution that might cover multiple workloads and multiple platforms. Right? So does that vendor work in Amazon and Azure and Google? Right? Does it have both serverless and serverless support? Can I have firewall only, or can I add additional capabilities on top of it? Now, traditionally, when I have a question, I go to Google for the answer. And when Google doesn't give me the answer in the first few clicks, especially with an IT question, well, I go to Gartner. When we look at what Gartner has to say about the fundamental solution building blocks, right, this is a model that they've shared with customers for years. Now, this model about minimum foundational security that every one of us need to our core workload protection, as we move up this stack, it is less critical to deploy those technologies, but it is relevant to the security of the workload. So if I was the Department of the Defense, if I was the IRS, well, my workloads are a lot more critical than if I am a local K-12 school district. That does not mean my workloads are not critical. but the amount of time, effort, and money I might invest to secure my nation's tax and critical cyber defense systems might be less than my local student information systems. Now, working from bottom up, as we moved into cloud, a lot of the things in the basic hardening and configuration and vulnerability management may or may not be handled by your cloud provider. And as we talked in the beginning as it relates to the shared responsibility model, how much ownership and responsibility for each of these is going to vary based upon whether you're using software as a service, platform as a service, infrastructure as a service, or if you've built it yourself. Now, when we work up from bottom, let's be honest, our clouds have some basic network firewalls. They have access control lists. They have some logging. They can do some segmentation. But the key here is in each one of these cloud providers is they provide the basic integration. And every step along the way, you can bring a vendor with you. You have that option to share the responsibility. And where are the places that I want to augment and enhance the cloud native capabilities with a third-party vendor. Now, let's start from the bottom of this period and work our way up. When we think about the posture management, right? As you lift and shift and move a workload, whether it's serverful or serverless, is it configured according to best practice, regulatory compliance, and other benchmarks that I follow? Now, this might be of my IaaS. This could be of my serverless functions. This could be of my containers, whether I'm using them as a service or building the containers in my own traditional environments. Or maybe even have that posture management to look at the containers as they're being built and packaged and deployed as well. Now, in that second layer is around the network security itself. And as one of my colleagues likes to say, Greg, there is no cloud. There's only someone else's computer. And even though we're using serverless, it's still software on hardware talking through network to users and devices. And there's network security along the way. It could just be basic access control lists. You might choose to deploy various services endpoints to route traffic through a VNet and a VPC, putting a third-party network virtual appliance to have traditional network security with IDS and IPS and proxy and data loss prevention. Again, different workloads require different level of protections. And that's up for you to decide, not for us to decide. In the third layer of this model, we talked about workload and runtime protection. So this might be adding additional layer of security in the operating system, embedding it within the web server itself, acting as an ingress or egress proxy at the container layer. And this may also now start to involve API level of integration. And whether we're implementing our own schema validation, we've got web application firewalls to have dynamic learning. There are many different technologies along the way that we've implemented in the past, present, and future to specifically look within the web tiers and the application tiers and the database tiers. And now we're adding them at the container layer as well. Along the way, every one of these technologies are generating logs and audits and forensics that we're now stitching together to help identify attacks in real time, allowing us to detect what has happened and enable a response. And whether that's a manual response, whether that's an automated response, we have to generate the information, create the digital breadcrumb so that we can have the forensic analysis. And hopefully now we're using more technology and machine learning and artificial intelligence, and you're not just sending analysts to comb through endless amounts of logs and alerts. Right? We need the technology and the power to provide this threat detection using the computational intelligence of the systems behind us, and use the power of automation and orchestration to help increase the efficacy and the timeliness of our threat detection and ultimate response. And then lastly, and I hear this from people all the time, well, I'm running serverless, you know, I'm secure, right? You know, malware is not going to take over my application. My applications are vulnerable to the traditional attacks, and that's true. But there's new attacks. There's new ways in which bad actors out there are using the cloud against you for reconnaissance, discovery, brute force attacking, and ultimately embedding themselves in your code and embedding themselves in your pipeline and using the power to go fast as a vehicle for them to go fast as well. Now, I'm going to take one moment here as we kind of round into the last 15 minutes of our session today, and really focus in a combination of the posture management and the network security. It's the most foundational for all of us, and it's relevant in every one of our environments. Now, if we think about the beginning, right, we had router, we had firewall, we had load balancers, and it doesn't matter if it was Checkpoint or Cisco, if it's F5 or if it's Citrix, right, or whether you're running Windows or Linux as an example, or Oracle or SQL Server or MySQL. The point being is we had this traditional architecture in the physical world, and it started to migrate to cloud. And even though things looked a little bit the same, they're actually starting to be a lot different. And as I like to joke, though it's 90% the same, things are 10% different. And if you and me and we don't understand that 10%, we're 100% screwed. Because when we move it into Amazon or Azure or Google, and we're now starting to use cloud load balancers, cloud firewalls, cloud native routing and VPN and auto-scaling and DNS and virtualization as an example, well, our customers and our employees are taking advantage of this ability to do this on demand much faster. Right? I'm talking to some large banks in America that have hundreds of subscriptions in VNets and VPCs. Right? Another customer that's born in the cloud where they have 40 different environments that are all automated and orchestrated and deployed and tested and then deleted and redeployed dozens of times a day. And finding the people who know how to use these platforms and know how to use the technologies, that know how to think API first, automate first, and not point and click is the razor's edge we're sitting on today. Because what we've seen, and it's not us reporting this is Gartner and many other people out there, that most of the breaches that have happened in recent years, and this is not exclusive to cloud, but highlighted in cloud, are often due to misconfigurations. A poorly configured firewall makes a great router. A poorly configured IAM role makes a great security breach. And even though things look the same, they're different. Right? And now that we're handing the elements of configuration management for cloud native built into the API, built into the cloud provider, well, do we really want the developers owning all of the elements of the security? Developers and DevOps have a shared responsibility along with SecOps to build whatever the workload is, whether we're building it in our own private cloud on a VMware or KVM or Hyper-V-based hypervisor, and we're implementing virtual firewalls embedded in the hypervisor. Right, and though VMware NSX and Nutanix flows, and there are many other vendors that have software-defined solutions in the hypervisor, but it allows you to selectively steer a north-south flow into a software-defined gateway and no longer have to route it through that one big firewall or the one legacy load balancer as an example. And these software-based solutions can not just send into one instance, but they can scale it across multiple instances. And they can replicate it on demand with automation and orchestration, giving you a development environment, staging, production, that have mirrors of one another, but have the necessary security controls and are dynamically mapped to each and every one of those phases. Now, as we can imagine, and we've seen, when we own all the infrastructure, the compute, the storage, the network, the hypervisor, the software-defined this, the routers, the switches, right? It's a lot of moving parts and pieces, right? It has its own costs and complications as well. Now, these software-defined networks have evolved over time. They become much better at utilizing the software-defined network to automate and orchestrate the deployment and the segmentation to not just bridge within the hypervisor, but cross over into the physical as well. And not that Cisco ACI and NSXT are the only solutions in this space, but at some point the software in the hypervisor talks to a network. Right? The overlay and the underlay have to come together, right? And this is in your data center, or this is in Amazon's data center. Now, they're not necessarily using commercial products like ACI and NSX to do so, but they're creating a variety of different subnets within logical networks that are isolated from one another and can be automated and orchestrated and deployed on demand. And in these environments, you have a little bit more control in how we blend hardware and software together. But the key here is that using this software-defined data center, we enable a north-south flow. We enable an east-to-west flow. We determine from zone X to zone Y, I want firewall, load balancer, WAF, SSL inspection, proxy, DLP, threat mitigation, and on and on and on. Now, this environment, which has traditionally been very physical, right? My VMware servers, my Cisco UCS, my HP, my Dell, my IBM. As we lift and shift and move these things into the public marketplace, as I mentioned, you have the option to bring vendors along with you. This could be Checkpoint in the marketplace. This could be one of our competitors in the marketplace. And this is not limited to firewall only, but for WAFs and load balancers and other technologies as well. And you can work in conjunction with the software-defined data center to deploy these in highly available, highly elastic, automated and orchestrated ways. Right? And create these swim lanes that allow you to have inspection, layer 4 through 7 inspection that complements, augments, and enhances the cloud native, in addition to the capabilities that are built into the cloud itself. Now, this is a diagram from one of our blueprints and our best practices of how we create a front-end zone for north-south connectivity. We create a back-end zone for east-to-west security, and that can get deployed not just in Azure, as I'm showing in this environment, but the same blueprint we can apply within AWS. We can deploy it in Google, Oracle, AliCloud, and others. The API integrations are different. The best practices are the same. Now, as we've seen and we talked about earlier on, we're no longer just building these applications in traditional ways with virtual machines, legacy separation of web tiers, application tiers, and database. Well, these things are running now entirely as serverless functions and within our containers. It's allowing us to now use less compute resources and deploy at a much faster rate. Get additional layers of automation and orchestration and elasticity, and potentially deploy it as a service. Deploy it in your own Kubernetes environment, whether it's in your VNets and VPCs, or you're deploying it in your traditional on-premise, right? Because containers are not technology that are exclusive to public cloud. Containers as a service are a function of public cloud. But regardless of which one of these design methodologies that you're choosing, every one of them has the ability to be fully automated and orchestrated. And every one of these environments, we're all trying to move faster. But how do we enable you to move faster and stay secure? Because it's not about moving fast or staying secure. Those days are behind us. We must move faster and we must stay more secure. As we mentioned, there is no one product or process that will take care of all of those functions. But the recipe for automation and orchestration really revolves around 3 key pillars. First and foremost, we must continuously monitor our assets. It sounds simple, but we have to be watching what's going on. Because the moment we take our eyes off of it, the dogs start barking like we heard up above, and I apologize for the noise there. The second key thing for an automated security solution is something that builds in automated remediation. That allows you not to just monitor and detect and alert to what's going on, but fix things in an automated and orchestrated way. And not just shift them in production once they've been deployed and my vulnerability assessments have detected the issues. But how do we enable security along with DevOps to shift left and allow us to now plug into that pipeline and identify the risks and the vulnerabilities prior to the deployment? So if you think about a traditional CICD pipeline, and I don't care which tool you're using for it, whether Jenkins or otherwise, people are checking in code, right? It could come from a Visual Basic application. It could come from my Visual Studio. But when I check it into that repository, that automation and orchestration engine is starting to do a bunch of stuff. It's building the apps. It's running a series of tests. It's producing it into staging. It's running more tests. We've got to go live, we're moving to production. But along the way, if we're moving forth legacy security artifacts, Well, it's great that DevOps got the build and it passed the regression test and we went live in 5 minutes. But is it good if we went out there with shared access keys that we knew were compromised? If we're deploying with identity and access roles that don't align to best practice and least privilege? We're using libraries that have known vulnerabilities? Because the infrastructure as code that's plugging into this, right, is coming from many different places, right? We're using the native Azure ARM templates or CloudFormation templates, or building those heat YAML scripts to roll this infrastructure out. Or maybe we're using GitHub as a code repo, and we're building our artifacts using Ansible and Terraform as an example. And these are not the only vendors that are out there. But rather than waiting till the artifacts have been deployed in the public cloud, rather than waiting till we have the virtual machines live with a public IP address and has been attached to the internet gateway, and now the whole world can see that port 443, I'm running a legacy version of Apache and SSL that has vulnerabilities, that has known compromises. And oh, by the way, as I joked, a poorly configured firewall makes a great router. We've opened up that security group to the world. So when we plug into this CICD pipeline with a security mentality, well, what are we trying to look for? Right? First and foremost, we want to look inside that infrastructure as code, because it contains so many bits of information about the configuration of the virtual machines, the route tables, the load balancers, the networks as an example. And it might live in a CloudFormation template or an ARM template. It might live in heat YAML. It's really just JSON, right? We're parsing the JSON and we're looking for pieces of information that are embedded in it, right? We're also looking within the code that's maybe put into that Lambda function as an example. We're looking inside the identity and access management roles that are needed to not only deploy the application, but for the application to run. Does this Lambda function need a full IAM role for S3 across all operations and all services? Does this Lambda function need full access to RDS to query all table spaces? Or when we think about those access keys, the access keys that we use to access the tools, the access keys that are shared for the application layer to communicate to one another, the access keys that we're using for SSH or RDP access into the virtual machines. Am I using the same ones in my development and staging and production? Are they the same access keys I left in my Dropbox and OneDrive accidentally? Or how about some of the default credentials that are embedded in these applications? Right, I've deployed this WordPress or Postgres or MySQL. Well, do they have an admin interface that's turned on by default? Does it have weak credentials by default? Did I just roll out a database that has MySQL as a username and password? And lastly, am I using applications and packing containers that have known vulnerable libraries? Because when we look at these new artifacts, right, it's no longer about scanning an operating system in the application. Well, maybe I need to scan the container, or I need to scan the serverless function. And we shared a lot of information along the way. I hope you took a little bit from this, and that, one, SecOps can keep up with DevOps. We have the know-how, we have the capabilities, we have the tools and the technology. Don't resist the speed to go, don't resist to go fast. But understand that we have to be secure. Thank you, Elliot. Slow and steady wins the race. But we have to enable ourselves to go fast and go securely. So don't give up and go home. Understand that security can shift left along with you. That you can automate and orchestrate the deployment of security, the configuration of security, and have your security shift left as part of the process. Thanks for joining us today. I hope you learned a little bit from our lesson today. And for those of you who want to find me online, you can follow me at pepper_Greg on Twitter, or reach out to me directly via old school snail mail email, gpepper@checkpoint.com. Thanks for your time, and make it a great day.